Hi guys, welcome back to my channel. So today I'm just going to do some past papers for electrostatics. We're just going to go through a few questions. So the question is already on display. I'd suggest that you just pause and attempt the questions by yourselves because we have covered the theory. If you want to look at the theory that we've covered, I'm going to put the link so that you can be able to see that video first, and then you can be able to attempt these questions, right? So these are the questions. I'm just going to move them out of the screen. I hope you're going to pause and attempt, and then I'm going to work on each one of them, right? You're given a scenario. It says two metal spheres P and T are on insulated stands. They carry charges of positive 3 times 10 to the power of negative 9 coulombs and negative 6 times 10 to the power of negative 9 coulombs. And they're showing you P and T. They say the spheres are allowed to touch each other and then placed 1.5 meters apart, right? So the first question, it says, in which direction will electrons flow while spheres P and T are in contact? From P to T or T to P. So we learned in the last video that electrons will always flow from the more negative sphere. So between these two, it's going to be T that is more negative. So electrons are going to be flowing from T to P. So your correct answer here would be T to P. I'm just going to underline it. Then the next question says, calculate the net charge gained or lost by sphere P after the spheres have been in contact, right? So the charge gained or lost, not the charge after contact. So if you look at that question, before you can calculate the charge gained or lost, which is basically the change in the charge, you first have to find what is the new charge of on each sphere after they have been in contact, right? So you're going to use the formula. Q nu is equal to Q1 plus Q2 over 2, which we explained in the last video, right? And then from here, you're just going to substitute your values, including the signs. So it's going to be 3, and you add negative 6 over 2. You get an answer of 1.5, negative 1.5 nanocoulombs, right? So this is the charge on each sphere after contact. Remember that the charge gets shared equally between the two spheres. But you're trying to find the charge that was gained or lost by each of the spheres. So from here, you can find the change in the charge, which is going to be the final minus the initial charge, right? Your final for both, they're both going to be negatively charged. So you can either use P, the initial for P, or use the initial for T. All in all, you get the same magnitude as an answer, but obviously one is going to have, one would have gained electrons, the other one would have lost electrons. So one is going to be negative and the other one is going to be positive, right? So we're just going to use, let's use P. If we use P, then we get negative 1.5 minus negative 3. Actually, it was a positive 3. Then you get negative 4.5. Remember, it's in nanocoulombs, right? So this is the charge that was gained by sphere P. You can also do the same calculation for the charge that was lost by sphere T. Remember, we said the electrons are moving from T to P. So you get the same answer, but you can try it out for yourself. You get the same answer, but it's going to be a positive 4.5 nanocoulombs, right? Then the next question had said, calculate the number of electrons transferred during the process. So now we speak about quantization of charge. N is equal to Q over QE, right? So if you substitute into this formula, here you're going to be substituting your change in Q that you just calculated, because they said number of electrons transferred during the process, right? So you're going to have your negative 4.5 times 10 to the power of negative 9 and negative 1.6 times 10 to the power of negative 19, right? So remember, the charge on an electron and the charge on a proton is the same. So if you had a positively charged, if you had used the change in charge for T, then you'd have a positive value here, have positive value here as well, right? So now, once you do your calculation, you should get 2.81 times 10 to the power of 10 electrons, right? So your N, your number of electrons, is always going to be positive. That's why I'm saying when you have a negative charge or change in charge, then you use a negative 1.6 times 10 to the power of negative 19. If you had used the other sphere and got a positive change in Q, then you're going to use a positive 1.6 times 10 to the power of negative 19, right? Then the next question says a third sphere R carrying a charge of negative 3 times 10 to the power of negative 9 coulombs is now placed between P and T, a distance of 1 meter from T. Calculate the net force experienced by B as a result of its interaction with P and T, right? So now they introduced a new sphere R, and then you need to find the net force. But before doing the net force, it is always important for you to first sort of understand the scenario and personalize it. That's what I always say. And in such a way that it's going to be easy for you to understand how to attack the question, right? So if you look at this question, they say, now let's draw out what they're telling us. They say you had P, sphere P, you also had a sphere T. That's what you had originally. These two are 1.5 meters apart. Now they say 1 meter from T, so from T, 1 meter from T, they introduce the sphere R. The distance from here to here is 1 meter, right? And then they say, so now if you look at the charges, remember that they touched and then they separated, which means the charge on P is what we had calculated in question 1.2, which is Q nu, negative 1.5 nanocoulombs. This is also negative 1.5 nanocoulombs, right? And R, you are told, has a charge of negative 3 times 10 to the power of negative 9 coulombs, which is also nanocoulombs, right? And if the distance between P and T is 1.5, then it's obvious that the distance between P and R must be 0.5 meters. That is the distance. Now, since force is a vector, so you're going to have to consider direction. Vectors have magnitude and direction. So you're going to have to choose one of the directions as positive and one as negative, right? So if I decide to choose right as positive, then I can be able to calculate. But before doing my calculations, I'm going to draw a free body diagram using electrostatic forces only. That is going to help me understand the force experienced by R due to T and P, right? So since R is negative and T is negative, it means R and T are going to repel each other, right? So if I'm drawing an electrostatic or a force, or rather a free body diagram using the electrostatic forces, then I expect the R to move towards the left due to the repulsive force between R and T, right? So R, since they repel each other, is going to move to the left. So if I draw now my free body diagram, the force experienced by R due to T is going to be towards the left. And now look again at the electrostatic force between P and R. So since these two are like charges, they're going to repel, which means R is going to be moving to the right due to its interaction with P. So I'm going to draw and label, this is the force experienced by R due to P, right? So now from this, I can be able to calculate the electrostatic force that is experienced by R due to each sphere. I'm going to use Coulomb's law. F is equal to K. Let's start with R, T. So it's going to be K, Q, R, Q, T over R squared. Then I substitute. This is Coulomb's constant, 9 times 10 to the power of 9. And then the charge on R is going to be 3 times 10 to the power of negative 9. Charge on T is going to be 1.5 times 10 to the power of negative 9. Here at the bottom, the distance between R and T is going to be the 1 squared, right? If you do your calculations, you're going to get 4.05 times 10 to the power of negative 8 newtons. This we had already said is going to be to the left, right? Do the same thing using Coulomb's law, but now for R and P, which is K, Q, R, Q, P over R squared. This is 9 times 10 to the power of 9. R is 3 times 10 to the power of negative 9. P is 1.5 times 10 to the power of negative 9. Right? And then the distance is 0.5 squared. When you do your calculations, you should get 1.62 times 10 to the power of negative 7 newtons. And this force we had said is going to be to the right. Okay? Now the question had said calculate the net force experienced by sphere R. So if I'm now talking about F net, I must consider the direction that I had picked here. So FRP, RP is going to be to the right, and then FRT is going to be to the left. So it's going to be FRP is positive, and then FRT is negative, right? So I find the vector sum to get the net force. So it's going to be 1.62 times 10 to the power of negative 7 minus 4.05 times 10 to the power of negative 8. You should get a positive answer, 1.215 times 10 to the power of negative 7 newtons to the right. So obviously, as expected, since although P and T have the same magnitude of charge, but because P and R are closer together, then it means there's a greater electrostatic force experienced between the two compared to R and T. That's why you have a net force that is towards the right. Okay, so we're going to move on to another question. Right, in this question again, it's good for you to pause, attempt the question, and then you can play the video. And if you have any more questions, you can even put them in the comment section. They say two small spheres X and Y are shown below. they give you the distance between the two, which is 0.2 meters. X has a charge of 6 times 10 to the power of negative 6 coulombs, and Y has positive 8 times 10 to the power of negative 6 coulombs. Calculate the magnitude of the electrostatic force experienced by the charged sphere X. So obviously X and Y experience the same electrostatic force, but they're going to be experiencing the same force but in different directions, right? From Newton's third law. So now they're saying I must calculate the magnitude of the electrostatic force, which I can easily do using Coulomb's law. Sorry about that noise, guys. There's a bit of a thunderstorm this side, but I just had to record content for you. So here we can use Coulomb's law. We've been given the magnitude of the charges, so it's 6 times 10 to the power of negative 6, and it's 8 times 10 to the power of negative 6. And the distance we are also given in meters, which means we don't have to do any conversions, right? And then you'll get an answer of 10.8 newtons. But now they've been specific to say the magnitude of the electrostatic force experienced by charge X. If they had said calculate the charge or the electrostatic force experienced by charge sphere X, then you'd also have to indicate the direction, right? So remember we discussed the direction before in the previous question. We said you have two like charges, they repel each other, which means X would move to the left due to sphere Y. So I'm just going to put it in brackets because for this question, it is not necessary to indicate the direction, right? And then 2.2 says, draw a vector diagram showing all the electrostatic forces and the net electrostatic force experienced by Y due to the presence of charged sphere X and Z. So they've introduced a Z of unknown negative charge, right? Place the distance of 0.3 below Y. Now they say draw a vector diagram. It's important that they say vector diagram. So when you draw a vector diagram, unlike when you draw a free body diagram, which has a dot and then has the arrows representing the forces or the vectors, for the vector diagram, we don't put a dot. We draw a small Cartesian plane and start drawing our forces from there. So when you're drawing a vector diagram, just going to move this one away, you can either use the tail to head method or the tail to tail method. I'm going to show you both, right? So let's look at 2.2. You can either use the tail to tail method. You draw a small Cartesian plane. This is tail to tail. And from the origin, then you draw the force experienced by each, or rather by the sphere due to the other spheres. So they said you're drawing the vector diagram for the net electrostatic force experienced by Y. So X and Y were both positive, right? If you remember that, which means we had said they're going to repel each other. So Y is going to move to the right due to X, right? So you're going to have F, this is F, I'm going to call it XY. And then Z, the new sphere that they introduced, is a negatively charged sphere, which means Y, which is positive, is going to attract Z. They're going to be attracted to each other, which means Y is going to move down. F, I'm going to call this one, okay, let me label it this side. F, Y, Z. Sorry about that. Y is going to move down due to the force between Y and Z, right? And then they say also include the net force. So that's when we use the parallelogram method for the tail-to-tail method. We use the parallelogram to write the direction of the net force. So you just extend, and again from the origin you draw your F net, your resultant. So your direction, the direction of the net force, your theta would be here, or you can use the angle here, either or, right? Or you can use, I said there's two methods. You can use the tail to head method. Start from the origin, you draw your first vector. Let's draw the f, x, y. And then from the head of the first vector, you draw your second vector, which is f, y, z. And then from the tail of your first vector, from your origin, or the tail of your first vector, to the head of your last vector, then you draw your F net, right? Your angle, direction of the net force is going to be here. So as you can see from these two diagrams, you can be able to use trig ratios to find the direction of the net force, right? So now the next question said the magnitude of the net electrostatic force experienced by a charged sphere Y is 15.20 newtons. Calculate the charge on sphere Z, right? So now from here, they give you the magnitude of F net. If you look here, they give you the magnitude of F net. They tell you F net is 15.20 newtons, right? From the previous calculations, 2.1, this we already calculated and we found to be 10.8 newtons, right? Remember, sphere X and Y, they experience the same magnitude of electrostatic force, right? So that 10.8 we got, that we had calculated as experienced by X, is also experienced by Y. So that's where I get the 10.8 newtons from. So now from here, the only thing that is unknown is this one. So there's a couple of ways in which you can approach the question. I'm going to choose to approach it using just the trig ratios. So we know from Pythagoras theorem that this would be a right angled, obviously, triangle. This would be your opposite side, this would be your adjacent side, and this would be your hypotenuse, right? So if I say F net is equal to, or F net squared is equal to fxy squared plus fyz squared, right? This I've been given as 15.2 squared, and this I've calculated as 10.8 squared. Then I can be able to get the magnitude of fyz, right? So from here, if you do your transposing, you get fyz squared is 15.2 squared minus 10.8 squared. You get your square root on both sides. Then your answer should be 2.098 newtons. So remember, the answer we always round off at the end. I've rounded off here on paper, but on the calculator I'm going to continue using the full answer to get an accurate final answer until the last step, right? So now I've got fyz, which means I can just simply use Coulomb's law to find out the charge on z. So I can use Coulomb's law, which is fyz is equal to k qy qz, which is all over r x, it's actually y z squared. This I've calculated as 2.098, and this is 9 times 10 to the power of 9 Coulomb's constant, y I have as 8 times 10 to the power of negative 6, right? And then qz is what is unknown. The distance between y and z is 0.3 all squared, right? So once you do your calculations here, you should get qz is equal to 2.62 times 10 to the power of negative 6 coulombs, right? So let me know on the comment section if you found that helpful, and also you can make suggestions of other kinds of questions that you'd like for me to tackle. In the next video, where I'm going to be doing calculations, exam prep questions, I'm going to also bring in the ones that have the string, tension, and so on, right? So you can also make some suggestions of maybe some papers that you've tried before that you'd like to be done here on the channel. Thank you for tuning in. Please subscribe. I'll see you in the next video.